Recording yet? Hello. Why does it take so long for this thing to start recording? I don't know. All right, boys and girls, here we have the first video in the APR standard review for the spring 2019 second semester Math 3 final exam review. As I say as a disclaimer on all, wow, I shouldn't have used that color. On all of these videos, this list, this video series, this review topic is not all inclusive. You are responsible for studying everything we've learned through the entire year. Okay? So look at this instructions really quick. Sketch a polynomial with the given characteristics. If the graph is not possible to sketch, explain why. Okay? So we're going to sketch these on our own. So let's look at this description right here real quick. See if you guys remember. I want something that's degree 5. It has an absolute minimum at x equals 3. It has two real roots, and it has this end behavior. Okay? So degree 5, this end behavior. Degree 5, this end behavior. That checks, doesn't it? That makes sense? How about this statement right here? Absolute minimum at x equals 3. So I want my absolute minimum to be on this vertical line somewhere. Absolute minimum with this end behavior. Is that possible? Why is it not possible? Because you cannot have an absolute minimum with that end behavior that matches that degree. If you tried to put a minimum at x equals 3, oh look, the end behavior goes down over here, you can't have an absolute minimum. So that's why it's not possible. Okay, let's go on to this one. We have a negative a value. Does that check with this end behavior? And it's degree 6. Does that check with this end behavior? Sure does. It wants two double roots. Do you guys remember what happens for double roots? Bounces off the x-axis. It has an absolute maximum at x equals 5. Now I remember when we went through this test last semester, a lot of students were making 5 right here for the y value. No, you want to choose some y value that's at x equals 5. Let's just call that our absolute maximum. Let's make sure this is degree 6 and two double roots. Okay, this is going to be interesting. Let's see. How about there's one double root. Let's see. Yeah. There's another double root. Is that a degree 6? Okay. Now I remember on IF, by the way, to make sure this is degree 6, Carnegie taught it slightly different than how I taught it, which is slightly different than Pearson taught it. You can count the degree by counting the number of increasing or decreasing intervals. There's an increasing, that's 1, 2, 3, 4, 5, 6. That's how you can make sure it's degree 6. I taught you guys to start 1 and count the turns. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 to be degree 6. Do you guys remember that? So you can figure out either way. Okay, let's continue into this last one, factor and sketch this polynomial. The first thing you should always do whenever you're given an equation or an expression is try to factor out a GCF. What's the GCF of this right here? Somebody say 2x. 2x. Now that x is going to be a 0, isn't it? Yes, it is. If I factor out a 2x, I get x squared minus x minus 12. Now that's a lot easier to factor than what you started off looking at, right? Isn't that minus 4 plus 3? Makes sense? So we have 2x, x minus 4, and x plus 3. Now it equals 0 to sketch. Now Ivana, here's what you were talking about, the zero product property thing. What are the zeros? This is the x-intercept. What's the zeros of each of these factors? What's the 0 from this one? Somebody say it. 0. What's the 0 from this one? 4. And the 0 from this one? Negative 3. Is this a cubic? What's the end behavior of this function? 2 means the right end is up. Odd means the left end is down. Let's plot our zeros there, and there. Do we have a y-intercept? Nope, it's right there because it's 0. We know this end behavior, so you just go Done. Piece of cake, yeah? Do you guys remember all this stuff? Okay, that's it for that video.